Alright, good morning, cheetahs. So make sure that you are 100% on task. Make sure that you give our guest teacher a great experience. I believe you have Miss De La Torre. She's going to be here today to be a guest teacher. Make sure that you're 100% on task, voice level 0, and that you make it to your field trip on Friday next week. I'm the one staying behind, so you would be staying with me if your name gets written down. Alright, so here we go. So, good morning. I'm sorry I'm not here today. As I said, I've not been feeling well, so finally I'm going to go to the doctor's. And please make sure to complete your task today. You're going to have to take some Cornell notes. They are due at the back of the classroom. Okay? Complete your IXL G1, G2. Complete it to 80 SMART score. Then complete your quiz. Okay, this quiz grade is in today. So please make sure you get your quiz done on quizizz.com, okay? So quizizz.com. Okay, SMART score 80. Study for your interim. The videos are up. Grades in go in today for all that you do. Alright guys, so go ahead and start filling out your Cornell notes. Okay, so we're talking about scientific notation. Remember that you're going to have to use these notes on your quiz, okay? So you're going to complete the notes. Don't write this. Then you're going to go to quizzes. Right, you're going to take a quiz, use your notes, and then you're going to practice on IXL. So make sure these get done, okay? Alright. So, if you hear my daughter, ignore her. Scientific notation. Scientific notation is used to write really big numbers in a short way. Okay, so here we go, guys. Scientific notation, make sure that you write these notes. Standard notation is the way that we write our numbers, right? And so, for example, 280 million. Can be written as this, right? That's standard, a normal number. But then in scientific notation, okay, I'm going to call it SN in our notes now because I'm not going to write out scientific notation every time. The shorthanded way, so it's a short way of writing a really large number or really small. So for example, if you have 280 million, we can write that as 2.8 times 10 to the 8th power. These are equal, okay? They are equivalent. Okay, so how did I get that number? How do I know that that's a large number? Okay, so here we go. 2.8 times 10 to the 8th. Okay, right here, this is our first factor. Your first factor may or may not be a decimal. Okay, it could be 2 times 10 to the 8, right? But it cannot be 0.8, okay? There needs to be a whole number, okay? There has to be a whole number in front of the decimal. Okay, so here we go. The second part, this part, is your second factor. And it's always a power of 10. Okay. The power, oops. or exponent, right, tells you if you have a big number, a large value, right, or small value number, right? If it's positive, so if it's positive exponent, then that means large. And that means move to the right. You'll know what that means later. Okay, if it's a negative exponent, so if it was -8, okay, that means a negative means it's a small number. It means move, right? Because negative means move to the left. Okay, we're going to do some examples right now. So go ahead and pause if you need to, kind of catch up. Okay, in your summary, I'm going to come back and I'm going to write some problems down. Alright, we're going to come back here later. Okay, so go ahead and pause, rewind if you need to, and then I'm going to start the notes for the second page. Psych. I forgot to write the problems. Alright, so here's the problems that you're going to do. Practice problems.
Me?
No, not you. My daughter's here. She's like, me? Okay. Oops. Your homework, not your homework, but your review questions, and then you can move on to your quizzes. After you're done with your quizzes, do your IXLs. After you're done with your IXLs, then it's your PAT time. Okay, so here we go. How to convert, right? Doesn't that mean change? I'm going to put a triangle here for change. How to change, right? Scientific notation. So we're going to make a chart. Okay, so how to change. Again, if you hear my daughter, just ignore her, please. Okay, so on this side, we're going to have scientific notation. And over here, we're going to have regular notation. Or, yeah, regular notation or standard notation. So, okay, here we go. Take your number. You're going to look for your decimal. And we want to write it in a regular number, right? A regular number. So because you're going to take your decimal. Song is way too crazy. Okay, the exponent is positive. You don't need to do this every time. This is just for our notes. Exponent is positive. So which direction on the number line is positive? So you got to move right. How many times? 5. So 5. Oh my gosh. 5 times. 5 places. Okay, so then if I do that, I'm going to take 7.5, take your decimal, 1, 2, 3, 4, 5, drop your decimal. And your number is going to be, okay, 750,000. Okay, so I'll do another example. That was examples. Okay, another example. 3.8 times 10 to the 4. Okay, so again, it's positive. That means move to the right. So you take your number, 3.8, take your decimal, and then because it's positive, you're going to move to the right. 1, 2, 3, 4. 4 places. Drop your decimal. 1, 2, 3. Okay, so 38,000. So your number is actually 1,000. So because, again, positive exponents are big numbers. Okay? So now let's go ahead and do another example of negative exponents. Okay? 4.2 times 10 to the negative 3. Okay? So here we go. Same thing, you rewrite your number, 4.2, negative exponents. Negative exponents. So let's just take some notes really quick. Your exponent is negative. So that means you're going to move. Yes. Left. 3 places. Okay, I'm still recording. My students are going to hear you. So then you take your number, 4.2, take your decimal, and you're going to move to the left because negative, right? Your exponent is negative. So then you're going to go 1, 2, 3. Oh, that's it. Just 3. 1, 2, 3. Drop it. And then what's your number? You added 2 zeros. So look, it's actually a small number, right? 0.0042. So instead of writing 0.00042, right, you can write it in a shorthand way called scientific notation. Okay, let's do another example. 7.51. See, you still have a whole number. All right, times 10 to the negative 5. Again, your exponent is negative. You're going to move to the left. Okay, so take your decimal, 7.51. You're going to move to the, take your decimal, left, because it's negative. 1, 2, 3, 4, and 5. Drop it. 1, 2, 3, 4. So your scientific notation is actually this number, 0.000751. See, it's a very small number, but we can write it in scientific notation. Okay? All right. So we're going to go to the summary. Okay, so I want you to notice something. Okay, notice. I want you to notice something. There's 2 different things that I want you to notice, and then we're done with notes. You're going to go to quizzes after. Okay, if I were to do 7.5 times 10 to the 0, 7.5 times 10 to the 1, 7.5 times 10 to the 2, 7.5 times 10 to the 3. What numbers are these? Well, what do you know about anything to the 0? Isn't that just a 1? So what's 7.5 times 1? 7.5. Okay, cool. Anything to the 1 is itself, so it's really times 10. So you move the decimal, it's positive, it's 1. 1 to the right. Drop it. This is actually 75. Look at the difference. What's happening every time that your exponent is increasing? Okay, now this one. How many times are you going to move your decimal? 2 times. 1, 2. Drop it. So this is actually 750. Look, when my exponent increased, what happened to the decimal? Boom. Now you have 75. When you have 75, and you have, or 7.5, and then you have 2 decimal places that you're going to move, right? So every time, guys, aren't you just adding a 0? You're just multiplying by 10 every time. So when they ask you, how many times is 1 times 10 to the 4, how much larger is this than that? So this has 4 zeros. This has how many zeros? That's 5, that's 6. Okay, so this has 1, 2, 3, 4. 1, 2, 3, 4. But then to get these 2 more, don't I have to multiply by 10 2 more times? So then when you multiply 2 times, it's 2 times 10. 2 times larger, but not 2 times larger, it's times 10 times 10 larger, which is 10 squared. So that wouldn't that be 1 times 10 to the 6 over 1 times 10 to the 4, which equals 1 times 10 to the 2? Study this. Okay, for interim. Alright, so go ahead and go on to your quizzes. Actually, you know what? I forgot one more thing. And then you can go back to scientific notation, right? So if I give you a number, so convert back. So if I give you a number, 280 million, can you write this into scientific notation? Sure. You take your decimal. Shh, quiet, quiet, quiet. My daughter. You're going to move your decimal to give you a whole number. So 1, 2, 3, 4, 5, 6, 7, 8. So it's 2.8 times 10. And how many places? 8. It's a large number. Okay? So it needs to be a positive exponent. So what if I have 0.00000076? Well, aren't you going to move your decimal to give you a whole number? So it's definitely going to be 7.6. 1, 2, 3, 4, 5, 6. Drop the decimal. Times 10. Now it was a small number, so it needs to be a negative exponent. And you move 6 times. 1, 2, 3, 4, 5, 6 to give you a whole number. Remember, there has to be a whole number. All right. Now you can